Math is a wonderful thing. Math is a really cool thing.
Alright, we are now in Unit 7, Systems of Equations and Inequalities. On this video, we are going to learn how to use the graphing method on how to solve a linear system. A linear system is a set of two linear equations. So here's an example. We have two equations. The first equation is y equals negative 2x, and the second equation is y equals x plus 3. A linear system can also be written on this format. So what is the solution set of this system of equations? If a point makes both equations true, then that point must be the solution to the linear system. Let's try to find the solution set of this system. Does the point 0, 4 make both equations true? So we are going to plug in 0 to our x and 4 to our y's. So for the first equation, our y is equal to 4 equals negative 2 times our x is equal to 0. From here, we can say that 4 equals negative 2 times 0 is 0. So we have here 4 equals 0, which we know is a false statement. Since the first equation is already false, we can then say that the 0, 4 is not a solution to this system. So this one is no. Now, does the point 2, 5 make both equations true? So again, the first number will be our x, the second number will be our y, and then we'll just have to plug this one into our system. For our first equation, y is equal to 5, negative 2, x is equal to 2. So we will have here 5 equals negative 4, which is again a false statement. So the point 2, 5 is not a solution to this linear system. Now what about negative 1, 2? So the first number will be our x, the second number will be our y. Okay, so y is equal to 2, negative 2, x is equal to negative 1. So we have here 2 equals negative 2 times negative 1 is equal to positive 2. So the first equation is a true statement. Now let's try and plug in this point to our second equation. So y is equal to 2, x is equal to negative 1 plus 3. So we have here 2 equals negative 1 plus 3 is equal to 2. Alright, in our second equation, the point negative 1 and 2 is also a solution. Now since the point negative 1, 2 make both equations true, the solution to this system is negative 1, 2. So let's try to plot both equations in the same coordinate plane. So the first equation, we have y equals negative 2x. So let's try to use our slope and our y-intercept to find our 2 points. So the slope here is equal to negative 2 over 1 or 2 over negative 1. This can also be written as plus 0. So the y-intercept here is equal to 0. So to graph this line y equals negative 2x, let's start on the origin, and then I'm going to use the first slope. So my numerator is a negative, so I will have to go down twice, and my denominator is positive, I have to go to the right ones. So this will be my second point. Now in solving linear system, it's best to have more than 2 points. So we'll do the same method again. Go down twice, move to the right ones. Go down twice, move to the right ones. Now, same thing here. I have 2 over negative 1, so we can go up twice and move to the left once. Twice, left, up 2 times, left once. So this will be the graph of our first equation. Okay, for the second equation, we have y equals x plus 3. M is equal to 1 over 1, or we can say negative 1 over negative 1. Our y-intercept is equal to 3. So starting with the y-intercept 3, I'll use 1 over 1 first. I'll go up once, right once, up once, right once, up. Okay. Then negative 1 over negative 1, I'll have go down once to the left once, down, left, down once, left once. Okay, so from here, we can say that this will be the graph of my second line. Now, at what point do the two lines intersect? So the point of intersection is actually this, which is negative 1, comma 2. Compare this with our answer for number 4. Note that when we plug in negative 1 comma 2 to this system of equations, we were able to show that both equations will give us a true statement. So using the graphing method, the solution is actually the intersection of the two linear equations. So for this system of equations, the solution is negative 1 comma 2. An ordered pair that makes a linear equation true is called a solution. The point that the two lines intersect is the solution to the system. To solve a system of linear equations, the ordered pair must work for both equations. So how do we solve a linear system using graphing? So first, we have to put the equations in slope-intercept form or in standard form. Graph each equation on the same coordinate system, locate the point of intersection and write it down, and then verify that the point makes both equations true. Now we have three types of solution. First, we can have one solution. So this is the graph of a system that will have one solution. It's actually two lines that will intersect each other. No solution means just two parallel lines. And then infinitely many solutions means that we have the same line, meaning we have the same slope and the same y-intercept. So let's have our first example. Let's find the solution of this system using the graphing method. So first, we are going to graph y equals negative 2x. You can just add 0 here so that we can identify our y-intercept. So for the first equation, my m is equal to negative 2 over 1, or we can say 2 over negative 1. The y-intercept is equal to 0. Starting at the origin, using negative 2 over 1, we have to go down twice and then go to the right once. Go down twice, move to the right once, 2 down, 1 to the right. Let us extend our graph by finding more points. I have 2 over negative 1 also, so we can go up twice, move to the left once, 2 up, 1 left, 2 up, 1 left. So this is the graph of my first line. Okay, for the second line, the slope is negative 2 over 1, or we can say 2 over negative 1, and the y-intercept is equal to 3. So starting on the y-intercept equals 3, okay, the slope is negative 2 over 1, so I'll go down twice, go to the right once, 2 down, 1 right, 2 down, 1 right, 2 down, 1 right, or 2 over negative 1, we can go up twice, left once. So connecting these points, I will have this line. Note that these two lines are parallel to each other. They have the same slope, negative 2, and -2. It means that if we have a parallel lines, the solution is actually no solution. So here we don't have solution. So we can't verify this one, all right? Now for example number 2, the equations are given in standard form. Um, we can graph this using intercepts, or we can graph this using slope-intercept form. So, okay, we are going to solve this one using slope-intercept form. So for the first equation, let's rewrite this into this format: y equals mx plus b. So first I will add x to both sides. We'll have 2y equals 3 plus x. And then, you know what? It's better for us to write this as x plus 3. So x plus 3. And divide by 2, divide by 2, divide by 2. So our y is equal to 1/2 x plus 3 over 2. So our m is 1/2, or -1 over -2. And our y-intercept is equal to 3 over 2, or 1.5. Okay, so we are going to start 1 on the y-intercept 1.5. Let's use this slope 1/2. So go up once and go to the right twice, up once, right twice, up once, right twice. Or we can go down once to the left, go down once, 2 to the left, go down once, and then 2 to the left. So this will be the graph of my first line. Of course, if we have standard form, we can also use intercepts. So how do we graph using intercepts? If x is equal to 0, so x is 0, divide both sides by 2, your y is equal to 1.5. Then if y is 0, x will equal to -3. So if you're going to use intercepts, so my y-intercept is 1.5, which is over here, and then my x-intercept is -3 comma 0. So when you connect these two red points, you will end up getting the same line. Alright, so let's graph the second equation. For the second equation, we have 2x plus y equals 4. So first, let's subtract 2x to both sides. We'll get y equals -2x plus 4. So here our m is equal to -2 over 1, or we can use 2 over -1. B is equal to 4. Starting at 0 comma 4. Okay, let's use this slope -2 over 1. Go down twice, move to the right once, 2 down, 1 right, 2 down, 1 right, 2 down, 1 right, 2 down, 1 right. Or you can also use 2 over -1, so go up twice, go to the left once. When you connect all of these points, you will be able to find the graph of the second line. Again, when you use intercepts, you should be able to get the same line. So using intercepts, if x is 0, so x is 0, so we'll have y equals 4. And then if y is 0, okay, solving for x, divide by 2 both sides, we'll get x equals 2. So if you're going to use intercepts, I will have 0 comma 4 and then 2 comma 0. So connecting these 2 points will give us the same line. Okay, now the solution is the intersection of the 2 lines. In this case, we have an intersection which is located here. We just have to label this point, and that will be the solution. So this point is 1 comma 2. And this will be the solution. So how do we verify? So to verify, we just have to plug in this point to our linear system. So x is equals 1, y equals 2. So let's plug in. X is 1, y is equal to 2. Is this equal to 3? We have here 2 times 2 is 4, minus 1 is indeed equal to 3. So that's correct. So let's plug in here. X is equals 1, y equals 2. Is it equal to 4? 2 times 1 is 2, plus 2 is equal to 4. It is also correct. Now we verified that 1 comma 2 is indeed the correct solution for this linear system. Earlier, we don't have any solution because there's no intersection. Our example number 3. What is the solution to this system of equations? Well, since the graph are already given, we just have to get the intersection of the two lines. So the intersection is 1, 2, 3, that's negative 3, comma 1. And this will be the solution. Last example, verify if the given point is a solution to the system of equations. So our x here is 7, our y is equal to 6. We just have to plug in our x and y. So for the first equation, we have 2 times x, which is 7, minus 3, y equals 6. Is it equal to negative 4? So 2 times 7 equals 14. 3 times 6 is equal to 18, equals negative 4. Now 14 minus 8 is equal to negative 4. So the left side is equal to the right side. So this is a true statement. But we also have to check the other equation. Checking the other equation, we have 2, x is equal to 7, y equals 6. Is it equal to 4? So 2 times 7 is equal to 14 plus 6. This is equal to 4. 14 plus 6 is 20 equals 4. So this one is false. Since the point 7 comma 6 did not make both equations true, we are going to say that this point is not a solution. We have to remember that a point will be a solution only if both equations will be true after we plug in our point. Alright, that is our first topic on this unit. We will have more methods on how to solve system of linear equations in the upcoming videos.
Math is a wonderful thing. Math is a really cool